Welcome to qnawire.
A very important concept in chemistry, and especially when we're talking about the bonding of atoms, is polarity and dipole moment. And this is extremely important because this would tell us how different atoms would bind, how they're going to react, and how they would behave in a lab. So in this case, we have boron trifluoride reacting with ammonia. Boron trifluoride is what we call a Lewis acid, and ammonia is a Lewis base. So we're seeing a acid-base reaction, and we're going to understand this reaction using our concept of binding of electrons. So boron trifluoride looks like this. We have our central boron atom bound to 3 fluorine atoms, and all of the fluorine atoms have 3 lone pairs because they have a total of 7 valence electrons that they have to meet. Now, ammonia, we see a central nitrogen bound to 3 hydrogens, but we have a lone pair on that nitrogen atom. Now, what's going to happen when we add these two compounds together? We're going to get this compound where we have our boron and nitrogen atoms bound together. So now we're going to analyze this product, or in this case, we might call adduct, and we'll analyze it using electronegativity and polarity. So let's just zoom in on the structure so we understand it a little bit more. So this is our product of the reaction we just had. Remember, this piece is our boron trifluoride, and this piece was our ammonia. Now we have to understand this using electronegativity. And what we see here is we have a partial positive charge on our nitrogen atom and a partial negative charge on our boron atom. So we denote them with delta positive and delta negative. And now why is this the case? Why are we seeing a positive charge on nitrogen and a negative charge on boron? Well, this is because of the atoms that they're bound to. Boron is bound to fluorine and nitrogen is bound to hydrogen. Now, if you were to look at the periodic table and look at the trend of electronegativity, hydrogen is really not electronegative at all. And fluorine is the most electronegative atom on the entire periodic table. So what's going to happen is that the fluorines around this boron atom is going to pull electron density toward it because it's so electronegative. That's why we have that delta negative charge. They're pulling all these electrons toward it, and it's giving it this overall negative charge. So what's going to happen is that in this entire product, those fluorines is going to shift all of the electronegativity of our compound toward the boron. And that's why we see that boron has a delta negative charge. It's much more polar, way more polar than the nitrogen because of those fluorines. So I hope that this problem helped you understand not only how we can draw Lewis structures and the Lewis structures of an entire reaction, but how we can analyze the product of that reaction using our concepts such as electronegativity, polarity, and electron density.